Using long division to divide polynomials. We are familiar with long division algorithm for ordinary arithmetic. We begin by dividing into the digits of the dividend that have the greatest place value. We divide, multiply, subtract, including the digit in the next place value position, and repeat. So for example, let's divide 178 by 3. So if we take 3 and we're going to divide that into 178, our first question is to ask ourselves, okay, well, what do we need to multiply by 3 to get 17? Well, we can say that we're going to multiply it by 5. So the next step is to say, okay, what do we do with the 5? Well, we got to multiply it by 3, so 5 times 3 is going to give us 15. And then the next step that we need to do is we're going to subtract, or we can say that we change the sign. So the 15 now becomes minus 15, and then 17 minus 15 is 2. Now the next step is we want to bring down the value of 8. Now we have 28, and now we're going to ask ourselves, how many times does 3 go into 28? Well, we know the number is going to be 9. So then we take 9 and then we multiply it by 3. So 9 times 3 gives us 27. And then what do? We change the sign here because we're going to subtract. And so now we get an answer of 1. Now, can 3 go into 1? The answer is no. We're not looking for a decimal here. So what we can say here is this is 59 and 1 over 3. So this is saying that we have the quotient with the remainder over the divisor. Now, this also means this can also equal 59 plus 1/3, which means we can say the same thing here. We can say the quotient divided equals, we can say that that's quotient plus the remainder over the divisor. Now, another way to look at the solution is as a sum of parts. This should look familiar since it is the same method used to check division in elementary arithmetic. So the dividend, which is 178, we know that 3 represents the divisor, 59 is the quotient, and 1 represents the remainder. So the dividend is equal to the divisor times the quotient plus remainder. Well, the divisor is 3, the quotient is 59, and we're going to add the remainder. Well, 3 times 59 is 177, plus 1 gives us 178. Now, the reason why we're doing long division with our ordinary arithmetic is it's going to help us when we start dividing a polynomial by another polynomial. Now, we call this the division algorithm, and we will discuss it more formally after looking at an example. Division of polynomials that contain more than one term has similarities to long division of whole numbers. We can write a polynomial dividend as the product of the divisor and the quotient added to the remainder. The terms of the polynomial division correspond to the digits and place values of the whole number division. This method allows us to divide two polynomials. For example, if we were to divide 2x cubed minus 3x squared plus 4x plus 5 by x plus 2 using the long division algorithm, it would look like the following. Well, first, we know that this represents the dividend, and this is the dividend, and this is going to represent the divisor. So we're going to take x plus 2, and then we're going to divide it into the polynomial 2x cubed minus 3x squared plus 4x plus 5. Okay, so the first thing we need to do is we need to look at the first terms. So the first term here is x, And we're looking at the first term, which is 2x cubed. So over here, what I'm going to ask myself is, I'm going to take 2x cubed, and I'm going to divide that by the first term being x. Now I'm going to ask myself, what do I need to multiply by x to get 2x cubed? Or what's 2x cubed divided by x? Well, the answer to that is 2x squared. So we have 2x squared, and now we're going to multiply it through like we did in our previous example. Well, what's 2x squared times x? Well, that's going to give us 2x cubed. And what's 2x squared times 2? Well, that's going to give us plus 4x squared. Now remember here that we're going to have two terms, and we need to subtract those two terms. So that means we have to change the sign for that term, and we have to change the sign for that term. So now what we're going to do is now add. So 2x cubed minus 2x cubed gives us 0. Minus 3x squared plus minus 4x squared is going to give us negative 7x squared. And then we're going to bring down the 4x. So it's going to be plus 4x. Okay, now, again, now the first term is now what's left, which is negative 7x squared. And we're going to divide that again by the first term in the divisor, which is x. Well, negative 7x squared divided by x is negative 7x. So we're going to take minus 7x and we're going to multiply it through by those two terms. So we have minus 7x times x, which is minus 7x squared. Minus 7x times positive 2 is minus 14x. Now what we're going to do is we're going to again change the sign. So if you multiply this by negative, that's going to make that a positive, and then that's going to make it a positive. And so now, minus 7x squared plus 7x squared gives you 0, and plus 4x times plus 14x is 18x. And now we're going to bring down the value of 5. So we have 18x plus 5. So now we're going to ask ourselves, we have 18x, and then that's the first term that's left over. We want to divide it by the first term. So 18x divided by x gives us 18. So now we're going to add 18 up here, and then we're going to multiply it again through. So we can say that 18 times x is going to give us 18x, and 18 times 2 is going to give us plus 36. Now again, what we need to do is we need to change the signs of both terms. So we get minus 18x minus 18x is 0, and plus 5 minus 36 is minus 31. Okay, now, can x go into negative 31? Well, the answer is no. Okay, so now what do we need to do? Well, we need to identify that this represents the quotient. This represents the divisor, and this represents the remainder. So if we want to write this like we did above, recall that we have the quotient plus the remainder over the divisor. So the way we would write this is the following. We know that the quotient is 2x squared minus 7x plus 18. Now, we can write this in three different ways. We can write this as plus, and then the remainder is negative 31 over the divisor, which is x plus 2. Or we can write it in this version. We can write this as 2x squared minus 7x plus 18. And we can leave the minus there and then write 31 over x plus 2. Either or is okay. We just need to be careful of that. Now, another way of writing this is the following. Well, what do we know? We know that initially we know that it was 2x cubed minus 3x squared plus 4x plus 5, and we divided that by x plus 2. And what we got was 2x squared minus 7x plus 18. Now I'm going to write the minus 1 on the second one we did, minus 31 over x plus 2. So my question is, what is the LCD of these three terms? Well, the LCD is x plus 2. So if we multiply everything by x plus 2, then that means we would have 2x cubed minus 3x squared plus 4x plus 5, which is equal to 2x squared minus 7x plus 18, because that's one grouping, times x plus 2. And that means we'd have to simplify this one and this one, and this one and this one, and this is going to be minus 31. So I want you to look at the answers here, okay? So here it could be represented in either or. We can either write the answer in this form, or as I said earlier, this can be 2x squared minus 7x plus 18 plus negative 31 over x plus 2, or it can be in this form. So either or is okay. So you have three forms. And those three forms that it could possibly be is this form, this one, or this one. Okay? And again, in order to get the second one, we had to multiply both sides by the LCD. Now, we can identify the dividend, the divisor, the quotient, and the remainder. We can see that this represents the dividend, this represents the divisor, this is the quotient, and this is the remainder. And so writing the result in this manner illustrates the division algorithm. The division algorithm states that given a polynomial dividend f of x and a non-zero polynomial divisor d of x, where the degree of d of x is less than or equal to the degree of f of x, there exist unique polynomials q of x and r of x such that f of x is going to equal d of x times q of x plus r of x, which is what we see up here, where q of x represents the quotient, r of x represents the remainder. The remainder is either equal to 0 or has degree strictly less than d of x. And if the remainder is equal to 0, then d of x divides evenly into f of x. And this means that in this case, both d of x and q of x are factors of f of x.